So welcome to the deep dives. Today we're going deep on Mercury, the sun's closest planet. And you guys sent some really interesting stuff about it. It's a pretty wild place, right? So we'll try to break it all down and get the crazy speed it travels at, those insane temperature swings, the fact that its core is weirdly huge, and then there's even, the whole ice thing.
Yeah, it's pretty amazing how something we've seen in the sky for, forever can still be so mysterious. I mean, the ancient Assyrians were tracking it, and the Romans, they were the ones who named it after their god Mercury, the messenger god. Greek versions, Hermes, fast guy. And that name totally fits, right? Because Mercury just flies across the sky.
Yeah, you can just picture those guys watching it and being like, yep, that's Mercury for sure. But even though you can see it without a telescope, it stayed a mystery for a really long time. Mostly because it's always so close to the sun, so it's tough to get a good look. So let's get into it. What makes Mercury so strange? I guess we could start with its orbit and how it spins, because it's definitely not your average planet.
Right off the bat, the speed is what hits you. Mercury goes around the sun in just 88 Earth days. And that's the fastest orbit of any planet. Think about it, that's over 100,000 miles per hour on average. And all thanks to the sun's massive gravity pulling it along.
And it's not just fast, it's close too, right? The average distance is what? Something between 36 and 58 million kilometers from the sun? I mean, that's way closer than us. And there's something else, isn't there? It's not like a perfect circle around the sun, is it?
You got it. Mercury's orbit is what we call eccentric. It's basically stretched out. So sometimes it's closer to the sun, around 46 million kilometers, that's its closest point, or perihelion, and that's when it's really zipping. Then it swings out to almost 70 million kilometers, its furthest point, the aphelion. So the amount of sunlight and heat it gets changes a lot during its orbit.
Which explains those crazy temperature swings. We'll get to that later. Now, way back in 1639, Galileo figured something out about Mercury that was pretty big. It helped prove that everything revolves around the sun. What was that?
Well, Galileo noticed that Mercury goes through phases, just like our moon, crescent, half full, all that. And this proved that Mercury must be going around the sun, not us.
Right, because if it was going around us, we'd always see it fully lit, right? Now, for ages, people thought Mercury was tidally locked to the sun, meaning one side always faced it, like our moon does with Earth. But turns out, not so much.
Yeah, that was the thinking for a while. But then in the 60s, radar observations showed us something wild. It's not a simple one-to-one lock. Mercury's rotation is in a 3-to-2 resonance with its orbit. So for every 2 trips around the sun, it spins 3 times on its axis. A bit of a weird dance, you could say.
Okay, so it spins 1.5 times for each orbit. That's, kind of strange. Why doesn't it just spin once per orbit like we'd expect?
Well, it's that unusual resonance combined with its elliptical or, stretched out orbit that leads to some pretty odd timing. Its solar day, meaning the time from sunrise to sunrise, is about 176 Earth days. So basically 2 Mercury years for 1 full day-night cycle.
2 Mercury years? Whoa, that's messed up. What would it look like from Mercury's surface?
Let's imagine this. The sun rises, climbs in the sky, then it seems to slow down, even stop for a bit, and then it moves backwards for a few Earth days before finally setting. Then, a whole Mercury year later, it rises again. There are even places where you could see the sun rise, set, and rise again, all within 1 Mercury day.
Talk about confusing. So with all this weirdness going on with its orbit and spin, does it at least have normal seasons like we do?
Nope, not really. Mercury's axis is tilted at a really tiny angle, like almost 0 degrees. We're talking 0.027 degrees. So basically, no tilt means no real seasons. The amount of sunlight hitting different parts of the planet doesn't really change throughout its year.
So it's always roasting hot at the equator and always dim and cold at the poles.
Pretty much. And speaking of size, Mercury is actually the smallest planet in our solar system. Its diameter is just over 3,000 miles. That's about the size of the continental US, or a little bigger than our moon. It's even smaller than some of the moons around Jupiter and Saturn.
So a little guy in the planetary family, but it sounds like it's got some serious weight to it.
It does. Despite its size, Mercury is the 2nd densest planet in the solar system. Just a tad less dense than Earth. We're talking about 5.427 grams per cubic centimeter. Pretty packed, for sure.
So why is it so dense? What's it made of?
It's all about its makeup. Mercury is about 70% metal and 30% silicate rock, so way more metal than rock compared to planets like Earth or Venus.
And that metal is mostly iron, right? And I've heard it has this crazy huge core.
Absolutely. Mercury's core is absolutely massive compared to its size. It takes up about 85% of its radius. That's like 42% of its total mass. To compare, Earth's core is only about 55% of our radius. So Mercury is basically a giant metal ball with a thin, rocky shell.
So a huge core and a tiny planet. And that core has been doing some interesting things over billions of years, right? Like actually shrinking the whole planet.
Exactly. That huge iron core has been cooling down for, well, since Mercury formed, about 4.5 billion years. As it cooled, it shrank, and that pulled the planet's surface inwards. We're talking about a shrinkage of over 4 miles. And this shows up as these wrinkles or cliffs called roops all over the surface.
A shrinking, wrinkly planet. And even though it's smaller than Mars, it's almost as heavy, which again points to just how dense it is.
Right. Mercury's surface gravity is only a little bit weaker than Mars, even though Mars is way bigger. It's a testament to just how much mass is crammed into that small package.
So we've got a small, super dense planet made mostly of metal with a weird day-night cycle and no seasons. What's it actually like to be on the surface? It must be scorching, right?
You bet. Mercury has some of the most extreme temperature swings in the solar system. Because there's basically no atmosphere to trap heat, the day side can reach a blazing 800 degrees Fahrenheit. That's 430 Celsius. But then at night, the temperature plummets to 290 Fahrenheit, or Anagen 180 Celsius. We're talking over 1,000 degrees Fahrenheit difference.
Ouch, that's harsh. But I've also heard there might be some, well, colder places. Maybe even some ice.
You're right. There are some places on Mercury that are surprisingly chilly. Deep inside craters near the poles where the sun never shines, the temperature stays way below freezing, like 93 degrees Celsius. And that's where scientists found something really cool: water ice.
Wait, water ice? On the planet closest to the sun? How is that even possible?
It does seem kind of crazy, but it's true. It's probably ice from comets and asteroids that crashed into Mercury long ago. It got trapped in these super cold, permanently shadowed craters, safe from the sun's heat. So you could be standing on scorching hot ground and have ice just a short distance away. Talk about contrast.
So boiling hot and freezing cold all in one place. Mercury is full of surprises. So we mentioned there's basically no atmosphere. What's there instead?
It's got what we call an exosphere. It's super thin, like so thin that the atoms hardly ever bump into each other. It's mostly oxygen, sodium, hydrogen, helium, and some potassium. And these atoms are constantly being blasted off the surface by the solar wind. It's more like a spray of atoms than a real atmosphere.
So not much protection from the sun's radiation then. What about the surface itself? After billions of years out there, it must be pretty beat up, right?
Definitely. Mercury's surface is covered in craters. It looks a lot like our moon. All those craters tell us that it's been hit by asteroids and comets for billions of years, and also that there's not much geological activity to erase those scars.
And there's one crater that's particularly impressive, right? The Caloris Basin.
Oh yeah, Caloris Basin is one of the biggest impact craters in the whole solar system. It's somewhere between 963 and 1,600 kilometers across, depending on the source you look at. It was such a huge impact that it might have created this weird, jumbled up terrain on the opposite side of the planet. We call it weird terrain. It's a mess of hills and valleys, totally different from the cratered areas. We think the shock waves from the Caloris impact traveled through Mercury and messed up the surface on the other side.
One impact messing up an entire planet? That's kind of mind-blowing. But it's not all just craters, is it?
Nope. There are smoother areas too, called plains. We think these might be ancient lava flows, or places where lava filled in craters after impacts. And then there are these strange features called hollows. They're like shallow depressions with flat bottoms and no rims. Scientists think they might be formed by stuff evaporating from the surface. So even though it looks ancient, there might be some subtle changes still happening on Mercury's surface.
A little bit of activity on an old planet? That's cool. And I heard there's something special about how the craters are named.
There is. Unlike craters on the moon, which are named after scientists and explorers, Mercury's craters are named after artists, musicians, writers, and other cultural figures. You'll find craters named after Bach, Shakespeare, Tolstoy, even Dr. Seuss.
That's awesome. A little bit of art on a harsh metal world. Now we know Mercury has a magnetic field, which was a surprise because it spins so slowly, right?
Yeah, it was a big discovery. Even though it rotates slowly, Mercury has a measurable magnetic field. It's only about 1% as strong as Earth's, but it's there. And we think it's created by the movement of molten iron in its core, kind of like a dynamo.
You mentioned the dynamo effect, so the movement of the molten iron in the core. What about its slow rotation? What's causing that movement to create the magnetic field?
It's likely due to the convection currents within the liquid outer part of the core. As the planet cools down slowly, the heat is released from the interior, and this drives the movement of the liquid iron. Even though it's a slower rotation, these movements can still create the electrical currents needed for a magnetic field.
So even though it's spinning slowly, the inside is churning enough to make a magnetic field. And that field, although weak, still does something, right?
Definitely. It acts as a shield, deflecting some of the charged particles from the solar wind. This creates a small magnetosphere around the planet. But it's not a perfect shield. Some of those solar wind particles get through and interact with the exosphere. Scientists have even seen these things called magnetic tornadoes on Mercury. They happen when Mercury's magnetic field interacts with the solar wind, like when magnetic field lines break and then reconnect, releasing energy, and in Mercury's magnetosphere, this creates these swirling tornado-like structures of magnetic energy.
Magnetic tornadoes on Mercury, who knew? And there's something else strange about its magnetic field, right? It's not centered.
Yeah, it's off-center by about 20% of Mercury's radius. And that's unique among the rocky planets in our solar system. Scientists are still trying to figure out why it's like that. It suggests that the dynamo in Mercury's core is working a bit differently than in other planets.
More mysteries to solve. So we talked about Mercury today. What about its past? How did this strange little planet form, and how did it end up with such a huge metal core?
That's a big question, and scientists are still trying to piece it all together. There are a few ideas. One is that early in its life, Mercury got hit by something massive, a grazing impact that ripped away a lot of its outer layers, leaving mostly the core behind. Another idea is that the intense heat and radiation from the young sun vaporized a lot of the lighter rocky material, leaving the heavier metal behind. And then there's the super-Mercury theory, which suggests that Mercury was once much bigger, maybe twice its current size, but then a giant impact blasted away a huge chunk of its outer layers, leaving behind the smaller, denser planet we see today. There's some evidence for this, like these rare meteorites called albrights, which have a chemical composition that might match what we'd expect from a shattered super-Mercury.
So a violent past for little Mercury, whether it was a giant impact or the intense heat from the sun. And even though it doesn't seem very active now, there's evidence of volcanoes in its past, right?
Oh yeah, definitely. Those smooth plains we talked about, plus other features that look like old lava flows and volcanic ash, all point to a history of volcanic activity. Some of those old craters might have been filled with lava at some point. And of course, the planet's shrinking as its core cooled has created all those wrinkles and ridges on its surface.
So it's like we're peeling back layers of time on this tiny, hot world. And speaking of learning about Mercury, how do we even study a planet that's so close to the sun? It must be tricky to get a spacecraft there.
It is incredibly difficult. The sun's gravity is super strong, so it takes a lot of energy to slow down a spacecraft enough to get it into orbit around Mercury. That's why only a few missions have ever been there. The first one was Mariner 10 back in the 70s. It flew by Mercury 3 times and gave us our first good look at about half of its surface. Then in the 2010s, we had the Messenger mission, which actually orbited Mercury for several years and sent back a ton of data and pictures.
Messenger was a game changer, right? What were some of its big discoveries?
It confirmed the water ice in those polar craters, found evidence of lots of volcanic activity, measured the magnetic field and figured out it was off-center, studied the exosphere, and mapped the entire surface of Mercury in high resolution for the first time.
That's amazing. And there's another mission on its way right now, isn't there?
Yep, the Bepi-Colombo mission. It's a joint mission by the European Space Agency and the Japan Aerospace Exploration Agency. It launched in 2018 and should arrive at Mercury in late 2025. It has 2 orbiters that will study Mercury in even more detail, focusing on things like the magnetosphere, the exosphere, and the internal structure. So we're hoping to learn even more about how Mercury's magnetic field works, why it's off-center, and what its interior is really like. This is all really important because understanding Mercury helps us understand how rocky planets in general form and evolve, including our own Earth.
So more secrets of Mercury are waiting to be uncovered. So as we wrap this up, it's pretty clear that Mercury is way more than just a hot little dot near the sun.
You got it. It's an amazing world of extremes and contradictions. It's incredibly hot, but has ice. Looks ancient, but might still be changing. Spins slowly, but has a magnetic field. And its history is full of giant impacts and intense radiation, all of which have shaped it into the unique planet we see today.
It's kind of inspiring how tough little Mercury is. It's right next to the sun, and it's been through a lot, but it's still there, holding on to its secrets.
It makes you wonder what other weird and wonderful things are out there in the universe waiting to be discovered. What else might we find in extreme environments that seem impossible? It's definitely something to think about.
It is. Well, that's our deep dive into Mercury. Thanks for listening.
Thanks for having me.